Okay, welcome back to the plotting lesson, week 7 of the Geo-Python course. I'll continue straight away from this more advanced plotting with Pandas Matplotlib lesson over here. And those following probably have the CSC notebooks already open. You can find this notebook in the lesson 7 folder, advanced plotting notebook, and we will be using the same data set that we had downloaded during the first part of the lesson that can be found in the data folder. So instructions for downloading the data can be found in the first part of the lesson. Okay. Great. I'll clear the check marks for this part of the lesson. So we will continue a bit with plotting with Pandas and Matplotlib, basically recapping what Dave just explained to you. So in that way, nothing new, but we will learn to create this nice multi-panel plots, which is neat, and also helps us to understand a bit better the different elements of the plot and the different objects in Matplotlib. All right. So building on what Dave just showed you, and here we have an example of a 4-panel plot for 1 year of data, or kind of 4 seasons of data, winter, spring, summer, and autumn, from Helsinki-Vantaa airport in Celsius degrees plotted, so you can see how the 4 seasons look like in terms of temperatures in the main airport of Finland, and with these nice seasonal colors as well. So we will be creating a plot like this during this last part of the lesson. As mentioned, the data is already downloaded, weather observations from Helsinki-Vantaa airport. And let's get started. Just open the chat in case there would be anything coming up. Tools, we are using our Pandas and Matplotlib, and as Dave explained, already importing Pandas enables some of the tools, but then for more advanced control of the plot output, we also need to import this pyplot submodule in the Matplotlib library, and it's customary to do it, give it an alternative name, PLT. I recommend you already run this cell, as it takes a few moments to read in the data. Nothing new here, so we have this different amounts of white space delimiting the columns, no data values with this asterisk, so we get those as NaN values. In our data frame, we only read in these selected columns, and then, as Dave explained nicely, so we are parsing date times based on the characters in this year, month, day, hour, minute column, and then we will set that as an index, which is useful when plotting the data. We could also afterwards then alter the values in the x-axis, but this makes our lives easier if we have already a date time index in our data. At least mine went through. You could of course check data.head as always that it looks all right. So we have 3 columns now, as then the 4th one has been set as the index. And I'm creating a new column there just to check the length of data, which is then, well, close to 1 million rows of data. So quite a lot of data as input. Okay, I think everybody should be ready to go soon after reading in the data into a data frame. Oh yeah, there was a separate slot for checking the head. I was going ahead already previously. I'll pull up my notes here. Okay, so we are ready to move forward. At this point, as we will be converting the temperatures once more to Celsius from Fahrenheit, so let's do this renaming of the data. I create a dictionary with this key value pair. So the key is temp. Pandas will go and look for this value in the columns. If found, then rename it as temp using the rename method, and then replacing the original data frame with those values. And again, we can check data.head. Indeed, we have now renamed this temp as temp_f to be specific. So this was also nothing new in here, just as a reminder of how to rename columns using a key value pair dictionary. Okay, so then one more step before we go into plotting the data. This is actually strictly not necessary, but we will do this also just to teach you how to get rid of no data values. Those who have completed exercise 6 already had to figure this out on your own, maybe finding last year's course materials or then from Google. Maybe not in the head, yes. So there are no data values in the data and also in the kind of average temperatures column. And if we want to find out how many no data values we have, we can do, for example, like this. So there is a method isNA. IsNull is another method that does exactly the same thing. And this one returns true or false based on the information if this particular point of the data frame contained NaN values. So as we saw from here, for example, the first row, there's no max and min, so then it's true based on this isNA. And if we take a sum based on that data frame, then Pandas will give us sum for the true values, so the no data values in each column. So we can see that max and min columns are missing quite a lot of data, so most of the rows don't have this information, and then there's only a couple of rows in the temp_f that don't have NA. Just to improvise, I will show 2 other ways of figuring this out, because people were asking this during last week's exercise. So you could also do, if we just want to figure out in one column, so temp_f, we can do this isNA sum. That's the same thing, but just from this one specific column. As I mentioned, this isNull. It's actually the same method, but I was reading up on this yesterday, so it's from the kind of R vocabulary, so the vocabulary that's used in R data frames. I guess there and isNA and isNull would do a bit different things, but in Pandas, it's the same operation. And then logically, we could also, you might remember this count function that we used previously. So what that does is to return count of the kind of true or real values or existing values. So the count excludes rows with no data, right? So then logically we could do length of data frame minus the length of existing values would then equal the number of no data values. Okay. So this maybe helps you to think about the logic. We get true or false, we sum them, or then we count the true values and then take minus that from the length of the data frame. All right. That said, I will erase these 2 not to confuse you. So this is the one that we have in the lesson materials. And then we can drop those rows with no data values. It is, well, we can debate if it's a good thing to do that before plotting. For this case, as we have such a long data series, it's fine. It might be needed if saving the data to a specific format. For plotting map data, at least previously, you had to get rid of no data values some way. So Pandas has this dataframe.dropNA function. And then we specify based on which column. So we don't want to get rid of all the data. We only specify this list of columns. So temp F is the only one we want to use as the subset based on which NAs are removed. And then I add this in place equals true parameter. And what that does is that when I run this cell, it in place updates the data frame that I'm referring to. Okay. So another option would be to do data equals data drop NA and subset without in place. So then we would write all kind of rewrite the definition of that variable, or in this way, Pandas applies the function and updates the data frame. And this in place parameter is available in various different methods. I run that, and then I can check, maybe I check the length of the data now. So this is now after removing these no data values. And what was our original length of the data? It was 330,000 something, and now we have, 900 and then 920,000 something. So we have removed some rows from the data like this. Okay, this is a quite quick check your understanding, and maybe I already kind of spoiled the solution, but you could either stop and think about it or then test with code that what would happen if we removed all rows with any no data values from our data, also considering max and min columns. So if we remove rows with any no data value, what would happen? So think about this for a minute, or then write some code which helps you to test it out. And I will show this then in a bit. All right, I have some 15 green check marks. Maybe at least you hopefully were thinking about it. So as said in here, we drop the rows where this temp Fahrenheit column has no data values. So we dropped some 3,000 rows from here and there. If we would want to drop all, I could do drop NA like this. And notice I'm not putting this in place parameter inside the brackets. If you did so, let's then fix it later. And now, of course, my starting point is already the data frame with no data values from temp F removed. All right. And then if I want to know how much data I would have at this point, I can take the length of the output of that action. So after removing all rows with no data values, I would be left with 20,000 observations, which is quite a few data points, or very little data compared to the almost million rows in there. So in this case, we don't want to do this because then we will lose most of the data, and eventually we will be plotting the temperature Fahrenheit data. So this is something to pay attention to. You might have in the exercise done this instead of, I think you were asked to drop no data values only based on information in one column. So maybe you want to go and check your solutions there. Now, just to make sure that everybody's, that we didn't cause any additional trouble, you could check the length of the data frame that you have, and it should be something 900,000 and more. If you don't have it, you could go back up to this notebook where we read in the data and then not run whatever you did then in here. under the check your understanding. So now that we continue, you should have 920,000 something rows of data. If you don't have, maybe you can ask Dave to help you out, or just simply go up and read the data again from the input file, rename the columns, and continue from here. Okay, so that was dealing with no data values and calculating them. Well, one more step before actually plotting the data. So let's convert temperatures to Celsius, because at least that's more intuitive to me and probably most of the people following today. So we want to create once more, this is the last time during the lessons, a temp C column for the Celsius. And in there, we could create a function, but in this case, we will just do a one-liner with the Fahrenheit conversion formula, which goes like this. So we have the data, temp F column, column name in brackets, minus 32, and then divided by 1.8. That should be correct. Give you some few moments to type this in. So we create a new column which gets the value based on temp F minus 32 divided by 9/5. Okay. Data.head. And you can see that we have converted the temperatures. I'll do like this in case somebody is still doing the conversion. But now we get to the main point of this latter part of the lesson. I think, well, I'll take probably half an hour or so walking you through this. So we will start using subplots. You remember this 4-panel figure at the start of the notebook as motivation. So basically, subplots are figures with multiple plots in these panels. So we can have 1 times 2, so 2 plots next to each other, or 4 panels, or whatever. If you have 10 by 10 plot you want to create, that's possible. And if you do that with Python, you get always a standard output. Of course, you can make a layout in Microsoft Paint. Why not? But then that's more laborious, and you might cause some manual errors in there. So this is our goal in here, to have this 4-panel plot, and I'll explain the details once we work through it. And as you remember, we had these 4 seasons. So we want to first extract the 4 seasons from the data, right? And we do this using the lock, indexer, and conditional statements. In the interest of time, we have pre-filled the syntax for other months than winter. So let's do winter together to see what's going on in there. Let's create a variable that would be a data frame containing the rows that are from actually this one specific year or season, 2012-2013, winter. And that we do by using this data.lock that we have already discussed before. Again, we have the date information in the index. So we do the condition on the index. And then we should know what is winter. I think we learned that in the first grade in elementary school. It of course might be subjective to depending on which country you live in, but at least for a Finnish person, maybe winter starts on the 1st of December. And then if we want to set that as the kind of lower bound in our condition, so as Dave did in the previous lesson, we can pass this character string, so 2012, and then for the year, then 12 for the month, 01 for the day, and we can start from the midnight, so 0, 0, 0, 0. That would be our first condition to locate all the rows where this condition is true. I'll put that into brackets because we also need to, winter luckily ends, even though winter is coming, it also will end. Let's see how good of a winter we get this year. Then we have this at bitwise operator to say that this condition has to be true and also the second condition has to be true. So again, data.index, so the datetime index should be less than whenever spring starts. So, and by this definition, spring starts the 1st of March. So anything before that and after the 1st of December would be winter. So we have then 2013 03 for the month, 01 for the day, and then midnight. So then actually the 1st of March will be excluded from the condition. Okay, so this one would then select, locate the rows where these two conditions are true and store that into our new data frame called winter. And then in this case, how we are doing it, we will take only the temperature, Celsius temperature column for plotting into a separate variable. So winter temps equals winter temp C. So we will be eventually plotting these Pandas series. And the same logic goes for spring, summer, and autumn. And once we run this, I'll leave it in there and just check winter. I'll do like this. So we have a data frame with winter temperatures by hour, actually. And then we have the Celsius there, and then this winter temps is a Pandas series that contains information from the Celsius column. All right. I hope you had the time to type it in. Indeed, there's year, month, day, and then midnight as a character string, and the condition is based on the index values that we created when reading in the data. You could, of course, have a condition based on any of the columns as well, if that would fit your purposes. I will move on. If you didn't have time to type it in, you of course have the correct syntax at the course web pages that are now up to date. Okay, so we have now four Pandas series variables in memory for each season in the season winter 2012 until autumn 2013. And let's start plotting the data. The other seasons are already typed in, and I will plot winter temps. Plot. I'll just do this to show. So basically, you don't need to necessarily store it into a variable, but often we want to then store this plot into something called AX, for example. And now that we have 4 plots, we give them numbers, because then using that variable, we can then add these titles and adjustments later on. But if you just want to quickly plot something, you can just run the plotting command in Jupyter Lab. Okay, so that should work, and it has the temperatures. We see that it's been actually quite cold, -30 degrees already sometime in January. So pretty cold, but then also these nice slushy plus temperatures here and there, as it usually is in Helsinki and Helsinki-Vantaa Airport. I'll go through these. So Jupyter Notebook plots the data here for us nicely. And this is also, of course, always the good point to visually explore the data, check if everything is okay, are the values expected. So yeah, so it's a good point to use your brain to check the data that everything is all right. Just check the chat once more. All right. Okay, so then we continue. Now we have 4 sets of data instead of the 1 set of data that Dave plotted with you. So we'll do a bit more preparation in order to get this nice 4-panel plot as an output. As you can see, the temperature range, and quite logically, the temperature range is a bit different in the different seasons. So you remember we have this minus 30 degrees in January, but then we have over plus 20 degrees. Well, we even have had up to 30 Celsius degrees in the summer, which is quite nice. But when plotting data, it would be nice to have a standard y-axis to be actually able to compare the data, so that if we have plots next to each other, so that the values go logically if you visually compare the data, even though if the data is in separate plots. So for that, we want to find data bounds, so the maximum and minimum limits for our axes, and especially on the y-axis, because the time range is now same in all of these plots. And it's good to add a bit of, well, air or space. So if our minimum temperature was minus 30, then if we add, let's say, in this range of data, plus and minus 5 degrees gives us a bit of space around the data values, but not too much space to keep the focus on our data range. So we can, to make our plotting script easier to read, we will create this min temp and max, min temp variables, and max temp is already there, as you can see, but I'll walk you through this min temp so that we understand what's going on. So for example, we could do this, that we list the minimum values from all of these Pandas series that we have. So I'm here taking minimum value of this series, returns 1 floating point, same here, winter, spring, summer, temps and temp, let's see if there are some typos, and then finally autumn. Okay, this is now still a tuple, but I'm actually wanting to use a built-in function min. So I pass 1, 2, 3, 4 floating point values to this min function, which then stores the minimum value to this min temp. And at the same time, when I have this min temp then in memory, when the script runs through, I can take that value and then minus 5, so that we get a nice minimum limit for the y-axis. Oops, and then I probably have some typos or some syntax errors or something else. Winter temps, spring temps, summer temps, autumn temps. That always happens. Okay, so now it goes, min function worked, and then the same thing for the maximum. So for these floating point values, we use the max built-in function and add 5. So then we get these bounds for the y-axis, minus 35, maximum 35. And this will allow us to plot these separate plots nicely. like we did in here, so that the y-axis is harmonized. Okay. Sorry for scrolling up and down. And yes, so we have these variables now in memory. So now comes maybe the tricky part, but also the useful part. So we will now create the plot in a bit different way than in the first part of the lesson. And one standard way of doing plots with Matplotlib is to use this pyplot subplots function. And I'll write it in and then explain. It will return us two objects, a figure object and then subplot or subplots, depending on our settings. So we call plt subplots function. We pass number of rows, so n rows equals 2. So we have 2 rows of plots. N-cols stands for number of columns equals 2, and then big size that we can then specify. I think it is in inches in this case. So this is our syntax. And you can see that this syntax now creates kind of the template on which, or the canvas, so to speak, on which we will then add our data into these specific subplots. Let's spend a moment discussing this, and you will learn it better when you then repeat these. So plt subplots is the function we're using. Parameters specify the size of or how many subplots we have in which order. So for example, if I would change here, number of rows is 1, but then you see that my figure size is a bit off and so on. So we'll see later how to adjust this. I wanted to show the documentation quickly. I don't know if this helps, but indeed we're using this pyplot subplots with these specific parameters. And indeed it creates a figure. So the kind of figure is in a way the container that contains all these plot elements. And then a set of subplots. I think it's explained down here. So the AX is either a single axis, so you can think of that as the subplot, or an array of axes. So if we have multiple subplots, then we get an array of axes back. And then again, this axis, it is basically the plot or the subplot with the elements, the ticks, the labels, and all of this. So sometimes it might be a bit confusing. What is then the figure? What is the axis? And what's the difference? But trial and error often then is the best way to figure out where to, for example, ask for new labels or setting the figure size and so on. All right. Moving on, as I now mentioned that this AX or AXS plural, now that we have specified several subplots, we have an array of subplots. And actually, if I do like this, as in the instructions, so if you pay attention, so we have an array, so it's a NumPy array, which is basically a list. Let's think of it as a list. So list of things, and actually the outer list has 2 items. And then that again is a list of these subplots. And that's important to understand in the next part, which is readily written in here. So I hope you are following, but if this is still a bit unclear, don't worry. So we are now, just to make our syntax more clear, hopefully, and easier to explain. So we take these different subplots. So from the first list, the first item, from the first list, the second item, from the second list, the first item, and then from the second list, the second item into these new variables. So then we have these, we'll see soon which one is which out of these. So then it's later on just easier to type in this specific subplot out of these four subplots in here. All right. So you can run that, and we'll see soon how to refer to those. All right, so then we are soon ready to plot the data. There's quite a lot of code readily available. I hope it's easy to follow. Only thing we set before the actual plotting is a standard line width. So I put it into a variable, and we will see how we can add now winter to this 4-panel thing. And if my logic is correct, winter should go to this kind of right, is it the left-hand side? So the third, well, left-hand side upper corner subplot, and that is this like first list, first subplot in our figure subplots object. Okay, and what does that mean? So we have this winter temps series. We plot it, and instead of just plotting it and generating some default figure that would not be related to the other ones, we already have this canvas here, right? So we want to tell to Python to which of these subplots we put it, and this pandas plot function has this AX parameter which we can use for that. And now this upper left-hand corner subplot was called AX11. So we do that. At the same time, we can control the color of the line. And winter is logically blue, or the frozen. We could, of course, have some nice frozen purple. Then the line width, LW equals to our line width parameter, ylim that we defined just before this minimum and maximum plus minus 5. We pass as a list. Dave explained this before. Okay, so we do that for the winter. We plot it to this upper left-hand corner spring, upper right-hand corner summer temps, lower left-hand autumn temps to this lower right-hand corner. And once we do this, we can actually have these separate data frames plotted systematically into the same figure object. I'll scroll back up in case. But basically the syntax is the same as here, except for the color and then referring to the correct subplot. So conceptually, I think there's quite a lot of new things to grasp. So we're still plotting things. We're plotting the Pandas series, and we are creating this figure with subplots. But this is super useful. If you understand this, then you're also then able to control and modify and customize. Be creative when plotting the data. And that's what is the added value of creating plots with Python. You can create your own style and be systematic with your plots. Repeat this for every year or whatever. You can imagine putting this then inside a for loop or something else. Okay, I'll move on to the next part. So we will create this plot, this is already nice. Like we have all the data, the y-axis is systematic, the colors are there, but you can see that then the upper row of subplots gets kind of covered with the labels are not visible, which is not optimal. So we can start adjusting the details. In here, we're missing the y-axis labels and so on and so forth. So let's create a new figure with the same settings. And again, we just take these axes into new variables so that it's, well, quicker to type in. So you can just run that. And then this code block is ready. I'll just talk you through it. And then there's one final check your understanding, which I think we have time to do, then to check that you actually were following. So what is happening in here? We have the same code that before. We have line width we plot the data to these 4 different subplots with specific colors, but everything else is standard. Then we set a title for the whole figure. So we could also set titles for these subplots, but we want this kind of title above everything. So what are we doing? Seasonal temperature observations, Helsinki-Vantaa Airport. This is now new. So this is one way to adjust our label. So we add a bit of rotation in degrees to the axis. And this is a bit complicated syntax. You can check the details, but we use the Pyplot library and then these separate axes to access the tick labels and then rotating them. I won't go into the details, but this is one way of doing it. And then we add axis labels to each plot, or actually to the kind of bottom plots and then to the left side plots to be specific, so that it's logical to read. And in addition, using the same technique as Dave used to annotate, so add custom text to the plots, we label, instead of putting titles, we put a label on top of the plot area. We could also use the legend, plot legend for that. And at some point we also added the grid. Did I miss that one? Yes, so in here we had added this grid equals true. So that adds this grid in there. So you can just run the code above. So now it looks already nicer. These rotated labels don't get overlapped. It's easier to read the data with the grids. We have these labels, X and Y labels and the plot. I would add still maybe one thing that I was supposed to add to the lesson materials. There's this plt.tight layout, which might sometimes help to resolve this issue of labels being hidden. Let's see if this changes anything. Maybe not in our case that we are now rotating, but just to note that this plt tight layout is sometimes useful. Okay, so there's quite a lot of information in here, but that's at this point all we want to teach you about plotting. So how to plot individual plots, how to put things into subplots. And if Dave agrees, I would still want to allow you, I don't know if we have time for this. What do you think, Dave? But just to help you to go through this now, maybe for 5 minutes, you could take the code above here. And you actually also need to take this part where we create the subplots. So you could copy paste this one and then copy paste the plotting script and try to create kind of 2-panel figure with winter and summer temperatures. So start doing that, and Dave can correct me if we don't have time for that. So we will go until noon today to discuss general matters after this. But I suggest you try to do this so we get to wrap up this plotting lesson with you doing things individually. All right, guys, you got now some time to think about it. In the interest of time, I will show it now. So I hope that help you to process a bit what's going on. I already filled in here the solution for creating the correct template for the figure and subplots. So number of rows is 1. We want them side by side. For example, number of columns is 2. And then I reduced the figure size height to half, because otherwise we got these funny shaped plots that might be useful for something else. But this is now a good size for our plots. Okay. Next thing I will do is to use the best method in coding, which is copy paste. So I copy paste all of this code that is proven to work, and I just need to somehow know how to put it into this new plot. The task was to plot winter and summer temperatures, so I delete stuff related to spring and then autumn. I maybe leave the rest like that. So this will allow me to plot the data, but of course now I need to, first thing is maybe to, hope this doesn't confuse, I cut out the rest so that I can actually test what happens. So this might sound nice, but then won't give me the desired output, because this AX11, AX21 now refers to the old template. What I can do is that actually now, how to explain this quickly. So now that I have this one row and two columns, I actually have only one list of subplots, and how to refer to those to be able to plot these data into the correct cells is that I take this AXS that contains these subplots, and I put winter to the first one, and then summer to the second one. Okay, there we go. So, and I still have this YLim is okay, grid is there. So this looks already quite nice. So this was all about understanding lists and this subplot object that comes from there. So now that I have only one row of subplots, it's in one list, and I can refer to those using this list indices in here. That's most of it. Then I'll quickly show how to finalize this plot. I guess the main title is okay. I could of course change it into winter and summer observations, whatever. Then we want to rotate the axis. This might go a bit quickly, but I'll do it anyway. So we need to do that for two subplots, which were the first one in the list and then the second one in the list, like that. And then again, we want to have the label date for both of them, I guess. So that was winter, this is summer, and then we can only have this temperature. Well, we can have it also for both, why not? Or then only for the left-hand side plot, which would be winter. And this is very prone to typos happening, so let's see what happens at the end. That's already quite good. Maybe in the interest of time, I'll just drop the labels. And also this now, let's see. I might want not to display it. I guess this tight layout probably already displays the figure. There's now something going on. I think, yeah, maybe I even take the tight layout out. Yeah, that causes my title to go wrong. Okay. This is most of it, and the key was to understand how to refer to the subplots. This is not fair, but I copied from the lesson materials. So here, if I want to then add these labels, so I could just figure out which XY point in this XY plot is a good place to add the label, and then add it like that. And you have this solution on the course web page if you now are starting to figure it out, but didn't really have time to type everything in. All right, so I hope this helped to understand Matplotlib, plotting with pandas, subplots, and all of that. And do I see any questions related to this? Not so much. Maybe if Dave doesn't disagree, I could explain exercise. Okay, why were the plots printed twice? That's a very good question. So the plots were printed twice for some reason. One reason was this, that I had this big here at the end. Yeah, I'm not really sure why this will print it twice, while then the previous syntax didn't. What would happen here if I don't have this display plot? Let's see. So for some reason, maybe it's related to this having 2 rows of subplots or something, but this code by default doesn't display the plot. And then this one, without calling the figure, displays it. I'm not now sure which part of the code makes it not to display it. But indeed, if it doesn't show, you can call plt show or then call the figure object. So then you see it. Yeah, but good question. And it might then depend on your setting. If you're working in Jupyter Lab here, you get the figures displayed in here, but sometimes in other development environments, you get the figures into separate windows. And of course, finally, the goal was still to save it as a figure. Sorry, I'm still going on, but this was important. plt save fig winter, summer, png. So this would then give us a PNG image in the working directory. So plt save fig after creating the plot will save you the figure. Okay, I'm sure we could continue discussing this for 1 more hour, but let's move on. I'll explain the exercise briefly, and maybe Dave can then have some final words and mention what's the plan with the final project, which is then in addition to this exercise 7. We have set the deadline until next week's Friday. So this was now the last lesson. Next week there's no lesson, but feel free to ask on Slack. We'll be monitoring that. And we hope you complete this exercise 7 by the end of next week, so that then we can, after that, for these weekly exercises, deliver you the feedback and note if we can't find your exercises or something before then the final assessment. So that would be important. You can work in pairs if you want, or individually. And we have, compared to last year, we have now shortened this exercise quite a bit because we then have this final exercise on top of it. We have 2 problems which basically help you to further understand Matplotlib and plotting. The first one is quite nice one. You will need to do this kind of create some random data and plot it. So you'll get this candy plot, and if you want, you can also experiment with colors and everything. So there's some instructions on how to create this random data using NumPy, and then create your candy plot with very delicious colors. So this is quite a short problem, but helps you to understand Matplotlib better. And you need to save the figure to a file. And then the next one is about plotting temperatures from Helsinki-Vantaa, like this. So you should create this example plot using Pandas and Matplotlib, and adjust some things according to the instructions. And then if you want, this is optional, but you can then also practice this Pandas bokeh and make an interactive version of the same plot. So those 2 problems are related to this lesson. And then in addition, we indeed will release the final problem, which Dave might want to briefly explain. Do you want to share your screen or just?
Yeah, if I could share my screen, that would be good. Let's see here. Okay, so hopefully you can see my screen now. I've just given a kind of general overview of the exercise, and I just want to take a couple minutes to explain basically what you would need to do and the kind of idea behind why we're doing this a little bit differently for the final exercise. First off, the general plan for what you would do in the exercise is that we'll give you a data file and we'll give you some general instructions about how to analyze that data file. And you'll be given essentially a goal of producing a set of subplots using Pandas and Matplotlib to look at, in this case, seasonal temperature anomalies and in the data. So it will combine things that have come from basically the last, mainly from the last 3 or 4 lessons, but it's really coming across the entire course, as you can imagine, going back to the beginning of what we were doing, learning the very basics of Python. So the data file, when you read it in, you'll have to do things like read the file using Pandas, clean the data, which means removing no data values in this case, manipulating the data and calculating new things, so things that we've already been doing with the data frames, using a function or some functions to modify the data that's in the data frame, and then ultimately producing a plot at the end of all of those steps. You have the skills to do all of these things, but things are a little bit different this time because we are going to suggest, in fact, not suggest, we're going to require that you work individually on this exercise. I don't personally have a strong view about whether or not you talk with other students in the course. I think that we would say that that's fine for you to talk a little bit with one another, but the work that you turn in should be your own personal work in your own personal GitHub repository for this final exercise. So like the other exercises, you will have a link to create your copy of the exercise, and then you'll turn in your own notebook that should contain text that is generated by you and not text that you and your partner have produced, for instance. In addition, we're going to give you some general instructions, not detailed instructions like we have in the previous lessons. So you'll have a list of things that you should do, but we're not going to tell you kind of in detail that you should create this variable name and then do this and then do that and then do this. Instead, we'll give you the general overview of what the goal is, and we're going to see what you come up with, because we're really interested to see how you approach the task, how you take the skills that you've gained and use them to produce the final product that we hope to see at the end of this exercise. Another difference is that you're going to have an empty Jupyter notebook this time. So we will give you a notebook that basically doesn't have anything in it, and it will be free choice for you to set up the notebook. How do you want to use Markdown cells to describe what you're doing? How do you want to use the Python cells to perform your analysis and read things in? In total, this is worth 40 points. So it's a significant portion of the grades. First 60 points come from the earlier exercises, and then the remainder of the 100 points for the course in terms of how we sum things up will come from this exercise. So it's a significant thing in terms of the point total for the course. But in addition, you have more time to complete this. So the deadline for turning in the exercise would be 3 weeks from this Friday. So 5 o'clock on the 6th of November is the deadline to turn in this exercise. So we're giving you a bit more time to work on it because it is a little bit bigger task. And the last thing I want to say about it is that we are still finalizing the final exercise description and things like this. And it may be sometime tomorrow that's finished. We, of course, want to make sure that the instructors and graders combined read over the description of the exercise in detail so that we don't turn you loose with bad instructions or send you down the wrong path. So we want to make sure that everything is in good shape, since this is a new exercise, and we'll apologize that things aren't ready today, but you will have exercise number 7 that you can start on, and then we'll give you the instructions about the final exercise very soon so that you can then continue on to working on that in very little time, I hope. So that's the general picture. You'll get more details, like we said, in the next day or two. And I would say if you have any questions right now, I would personally be quite happy to take them. Otherwise, as I'm sure many of you are quite well aware, we are running out of time. In fact, we're maybe even a bit over time. But do you have any questions about this final exercise at this point? I think this hopefully gives you a picture of what the general idea is for the exercise. And I'll also say, I mean, we're looking for a way to sort of assess what you've learned individually. So this is a nice way for us to be able to do that. So those of you who are thinking strategically, maybe already figuring out that if you have done all of the exercises up to this point and received full points for those exercises, you could skip doing this and still scrape by with a 60 out of 100, which would get you a 1. Or I guess, yeah, I think you would be getting a 1 for your grade in the course. So it is also your choice to choose whether you want to do this at all, although we would certainly strongly encourage you to do so, because for no other reason than the fact that this is a fun way to see how much you've learned. But I'm not seeing any questions or anything urgent in chat. Of course, you can ask about things in Slack, and we will inform you as soon as the final exercise repository and description are available to you so that you can get started on that. If there's nothing else, I appreciate those of you who have stuck around to the very end here, and hope that that you feel like you've learned a few things in this course. It's a lot of fun for us to teach, and it's really awesome to see what you guys take from the course and go off and do, because it's really for those who enjoy doing the Python programming, it's cool that we see it. I mean, we see in the courses that we teach after this that you're doing stuff in Python, and that's a lot of fun for us to see you actually take what you've learned here and put it into use. So yeah, thanks for sticking around to the very end here. And Vuokko, would you like to say anything in closing?
Yeah, thanks everybody for the course. I think, well, from our perspective, I think this remote teaching has went well. I hope it's also been kind of supported your learning the way we have organized it this year. And yeah, I want to thank Dave again for nice collaboration, often in late hours of Tuesdays. But yeah, been fun. And of course, we want to acknowledge Henrikki Tenkonen as well for preparing the materials since many years. Yeah, and I'm happy to come. I will come tomorrow to the exercise session at 12:30 to check if there's any kind of bigger questions and help out. So if you have something you're wondering with about exercise 6 particularly, so I'm happy to walk you through the difficult parts tomorrow. So the point of the weekly exercises is for you to learn the stuff. So we want to support you in doing that.
Yeah, okay. Well, if that's it, I would also like to thank Vuokko for what's been a very enjoyable course. And we will see you in the exercise sessions Thursday and Friday this week. All right, that's it for us. Bye.
Good luck. Bye.